Covalent bond. With ionic compounds, we learn to give and receive, but now let's learn how to share. Covalent bonding. Covalent bonds are when atoms are held together by sharing electrons. Let's recall what is ionic bonding with sodium chloride. In sodium chloride, we had a metal that is sodium bonded to chlorine, that is a nonmetal. Sodium having 1 electron in the valence shell, and chlorine having 7 electrons in the valence shell. So sodium will give out this electron, getting to be a positive charge, and chlorine receiving this electron will get a negative charge, that is, an anion and a cation. In covalent bond, we have chlorine gas. In here we can see 2 atoms of chlorine that are joined together by sharing their electrons, and this is covalent bond. Now, when we talk about covalent bond, we talk about molecules. A molecule is a neutral group joined together by covalent bonds. In this example, we can see fluorine. Fluorine joined together, they're sharing their electrons in order to attain the octets. In the picture below, we can see the electrons shared. Now, there are different types of molecules. The first one is monatomic, like helium, diatomic, like oxygen, and triatomic, like water. Now let's compare between ionic and covalent bonding. When we talk about formula, ionic bonding is called chemical formula, whereas covalent bond is molecular formula. When we talk about melting point, ionic compounds have a high melting point. This is higher than room temperature, whereas covalent bond is lower than room temperature. The boiling point of ionic compounds is high, that is bigger than 200 degrees Celsius, whereas covalent is lower than 200 degrees Celsius. Ionic compounds will be at room temperature solid, and covalent compounds will be liquid or gases. And when we want an ionic compound, we will need a metal plus a nonmetal, whereas in covalent compounds we will need 2 or more nonmetals or a metalloid plus a nonmetal. Now let's see what a molecular formula can give us. Usually there are 2 things. The first one is the elements involved. In our case is hydrogen and oxygen. And the second is the amount of atoms of each element. In our example is 2 atoms of hydrogen and 1 atom of oxygen. Let's practice. In carbon dioxide, we will have 1 carbon and 2 oxygens. In peroxide, we will have 2 hydrogens and 2 oxygens. For salt, 1 sodium, 1 chlorine. Sulfuric acid, 2 hydrogens, 1 sulfur and 4 oxygens. And for sugar, we will have 6 carbons, 12 hydrogens and 6 oxygens. Now, covalent bond also follows the octet rule, but this time sharing electrons occur in order to attain the electron configuration of noble gases. Remember that helium, neon, argon, krypton, and xenon are the noble gases. Now, when we talk about molecular formula, we can have a single covalent bond is when 2 atoms are held together by sharing a pair of electrons. In our example, we have hydrogen with 1 electron each one. They will share their electron to attain the octet rule, in this case, the structure like helium, that is 2 electrons. Now, another way to represent it is to use the structural formula. In this time, we will represent the covalent bond by dashes. Every dash represents 2 electrons. And the molecular formula will be the times of the atoms that we have, in this case, H2. Now let's practice. Suppose that we have 2 atoms of hydrogen and 1 atom of oxygen having the molecule of water. Now the structural formula will be oxygen with one dash to one hydrogen and another dash to another hydrogen. The molecular formula will be H2O. Double covalent bond is when two atoms are held together by sharing two pairs of electrons. In our case, it's oxygen with another oxygen. And they can share a couple of electrons each one of them. The structural formula, back again with dashes, will give us O, two dashes, O. And the molecular formula, O2. Let's practice now with, back again, two oxygens and one carbon. Carbon needs to share two electrons with each one of the oxygens. So the structural formula will be carbon in the middle, two dashes with each oxygen. And the molecular formula will be CO2. Now we can have a triple covalent bond. Is when two atoms are held together by sharing three pairs of electrons. In our example is nitrogen atom 2 times, and each nitrogen to complete the octet rule will need to share 3 electrons. The structural formula represented with dashes, it will be nitrogen, 3 dashes, nitrogen. And the molecular formula, back again, N2. Let's practice with this, and this time we have 2 carbons and 2 hydrogens. The hydrogen needs only 1 electron from each carbon, but the carbon will need to share 3 electrons with the other carbon. So the structural formula will be represented having each carbon with a single dash with the oxygen and a triple dash with the other carbon. The molecular formula, C2H2. Now, there is a kind of bonding that is not typical, is kind of rare, and is a covalent bond, a coordinate covalent. This is a covalent bond in which one atom contributes in both bonding electrons. Check this out. This is carbon monoxide. In carbon monoxide, oxygen shares 2 electrons with the nearest carbon and is complete with that, its octet. But the carbon has only 6 electrons and it's needing still 2 more electrons. So carbon steals for a little moment those 2 electrons from oxygen and returns it immediately. So this is what is called coordinate covalent. Now, there are some structures called polyatomic ion. Poly meaning many. And actually, it's an ion with 2 or more atoms working as a unit with a charge but joined between them by covalent bond. In the example, we have phosphate, PO4, with -3 charge. Between phosphorus and oxygen is bonded by covalent bond. But in the presence of sodium, that is +1, they will join together in an ionic compound. If we take a look at the left, and we see some of the polyatomic ions like nitrate, nitrite, or chloride, chlorate, the ending of the polyatomic ions usually falls into 8 or 8. Now, bond dissociation energy is the energy required to break a bond between 2 covalent bonds. In our case, suppose that we have nitrogen. In order to break this nitrogen, we will need that bond dissociation energy. It will be able to separate this molecule. Resonance. Resonance is a structure that occurs when it's possible to draw 2 or more electron dot structures that have the same of electron pairs for a molecule. In our example is ozone. Ozone is the one that protects our planet and is represented with O3 as a molecular formula, can have these 2 structures and is called resonance. Thank you for watching.